Good afternoon, everybody. I guess you guys had good lunch, and typically, these types of sessions, these post-lunch sessions, are a little difficult, and I think the thing kind of strikes you not in the first presentation, and again yours were pretty interesting. So second, third, so we'll try to keep you guys as much engaged as possible, and make it as interesting as possible. The topic for today that I've chosen is happy factory. When we started looking at happiness in a factory, typically happiness is more individual, right? And it's more internal. But as a factory, I work for Omron, and Omron has a lot of factories around. And we started looking at this about 3 years back. And we started realizing, it's a difficult proposition. It is difficult to measure. It's difficult to validate. And, it could be subjective. So and then we started defining them. And when you look at happiness, we are talking about not instant gratification. We're talking about engagement. We're talking about working, connecting people, connecting machines, connecting your environment, making sure that you feel that you're supported by the environment, and so on and so forth. So, like I said, although happiness is individualistic, it's in the mind, but what we are trying to do here is to kind of create an environment, an external environment, where it starts to facilitate, bring out creativity in humans. We're all designed for creating new things, and also helping them be successful. So when we started again looking at these things, we also started to talk to academic institutions, and we are in progress to because since we have factories, we are able to test those types of parameters and then start to define them. I think it becomes slowly with evolution in manufacturing, this. We see this thing coming, with Society 5.0, where which defines any human being, any individual will be able to provide value at any place, anywhere he is, and we saw that when we were working in remotely during COVID times, and it becomes very critical for manufacturing companies to have an initiative in this direction to make to create a sustainable workforce. So I think it's fairly important to start thinking about this. So before we delve in, a little bit of let's delve into a little bit of history here, right? Maybe a few decades back, we started with the Industrial Revolution. And I think, over many decades, humans have been trying to create systems for betterment of humankind, right? And those were kind of appropriate at each of those, of those time periods. And, it was successful for probably that, time period, and slowly we start evolving. So when we looked at Industrial Revolution, again, it was for the benefit of humankind. We were trying to create abundance, right? We were trying to eradicate poverty. We were trying to eradicate or make have food for all, transportation, so on and so forth. So it was done for the betterment of society. But when it comes into the factory, right? You had, it was a sweatshop, and although the guys that were working in the factories were trying to help the society, I think they had the bad side. So Industrial Revolution was good, but we were looking at, we were looking at these operators trying to work with, with the machines, or even labor through, many difficulties. So let's get on. I don't know how many of you are industrial engineers here, but that's the period when industrial engineering started, right? Doing time and motion studies and things like that. So let's look at a comical video here. This is from a clip called Modern Times by Charlie Chaplin, close to about a century back. I'm pretty sure some of you have seen this. But it's a pretty interesting clip that looks at, it really portrays how, in a comical way, how, the factories were run. Well, in this case, you had, people realized that to be productive, you have to reduce your idle time. And, somebody came up and said, the lunch time takes a couple of hours, so we have to reduce lunch time, right? And I mean, I just love these mechanical systems. I mean, look at how it's been designed. So they said, okay, we have to reduce your lunch time, and they started having this feeding machine. So they come in, and on the production line, you have the feeding machine, and you have to be working continuously, but you're fed, right? So you've got all kinds of stuff, from soup to solid stuff, and guess what? With these machines, things go wrong, right? And mechanical systems, right? So a century back, but just imagine a century back. I mean, just this type of a thing, right? So I mean, it is comical, but it's people have really thought about this, and it is true, but. They have really thought about this as bringing in productivity. I mean, their ultimate goal was to help society, but the operators had the bad side, right? So it's and finally, they try to recover the system, but again, you start doing it again. Let's bring on the soup again. Go for testing. So, I mean, the goal was to help, but the direction of how they try to solve it, maybe a little bit off. But again, when you start looking at, but this is a real problem, right? So, but when we start looking at today, so we have a feeding robot. It's pretty much the same, except that we were focusing on just productivity and equipment and efficiency and things like that. But here, it's a human-centric innovation. I mean, it has evolved over time, but this is like comparing your cabinet Mark IV computers to your laptops, right? It's much more powerful, but again, human-centric. You're putting the human in the center, and it is directly causing happiness, to people. So it's on the society side. So now, we are looking at how these things evolve and how we can put these systems in factories to create a similar level of happiness, right? So let's start looking at the path towards harmony and harmony of people and machines, right? So when you start looking at it, we started with, I mean, again, this is the Industrial Revolution side. So the graph here on the top side is, sorry. So from here you've got the harmony, and then you've got the skills on this side. So you started with mass manual production. So you had a lot of laborers, skilled labor workforce, right? Trying to mass produce. And then you started introducing machines. That's when the disharmony started happening, right? Between man and people and machines. And we started to evolve that. to lean manufacturing. We started putting in systems to measure these inefficiencies and safety and whatnot, and started to look at lean manufacturing. And then, started to look at with robots and cobots. We started with collaborative manufacturing. Now we are, somewhere here, the autonomous and collaborative manufacturing. So when you looked at, this portion, it was purely mass production. Then starting to have mass customization, and now we are into personalized manufacturing, right? We're starting to produce quantity of one. So like I said, this portion here, you look at the disharmony starting to fall down, and the worker upskilling starting to go up, right? So when you look at some data, the work injuries and the work-related incidents in factories are primarily due to two things. One is the physical fatigue, muscular and skeletal issues, and then the stress, the anxiety, right? So when so when you want to make the individual, the operators contribute more, then you start providing them with the tools, and we start facilitating their contribution to the optimization of manufacturing workforce. So so you provide things like autonomous systems to reduce fatigue, robots to alleviate hard labor, and start to have tools like AI and others to make the system more predictable, right? See, I mean, if you look at it, when are we really unhappy? When we are really stressed, right? When we are fatigued, and we feel helpless. We don't, when we try to troubleshoot things and we don't have a support structure, and you're just there and just all by yourself, and machine break down in an unpredictable fashion. I think that's when the stress levels goes up and you start feeling unhappy. So those are the things. So this is what started happening, here when we started introducing machines. And then slowly, we started learning how to do this and started introducing all the tools to, reduce all those unpredictable breakdowns and things like that. On the worker upskilling side, obviously, compared to what we were 100 years back, we didn't have software back then. It was 95% construction, mechanical constructions, and maybe 5% of the rest of it. But if you look at it today, right, close to about 45% is software and engineering, right? So I think this is where we bring out the creativity in humans, and which we are all kind of designed for. So Omron, we have been working on how to create this harmonious relationship between humans and machines for probably over a decade. Some of you might have seen this. This is our ping pong robot. This is the 7th generation called Forpheus. So we have a robot. It's an industrial robot, and it plays ping pong, and this is like a doubles. There were versions where you had singles and things like that. So we use a lot of AI, vision, robotics, and sensing technologies to look at the player skill set, whether he's a novice, an expert, whether he's trying to learn, whether he's learning. So a lot of things, empathy, facial recognition, quite a lot of things. And also, based on the speed and things like that, we figure out whether the racket, the rubber in the racket is getting worn out. So a bunch of things. So it's a very interesting demo here. What we do is, these are industrial robots. What we do is, after we learn quite a lot from here, we apply them in our factories, right? And some of the pieces in our manufacturing. So So what we do is using the same type of adaptive AI vision and autonomous monitoring of operators, automatic recognition of positions and the arms and things like that. We are able to kind of start to visualize their proficiency level. We are able to look at the differentiation in productivity between an expert and a novice, and start to create a harmonious workplace through autonomous coaching. Just like what you saw in the ping pong area, ping pong robot, where it's not like competing with the robot. It's actually trying to coach how we play and how we improve, right? So we use the same kind of learnings from that to implement in our factories. So we use them, we collect, we do an AI analysis, and we also do a real-time feedback. So if you look at a beginner versus a skilled worker, at the end of the day, you actually are able to see how you performed and what you have to change to kind of become an expert. So through all these things, we kind of facilitate, we turn operators into creators. I mean, we also are seeing a trend to have from IoT, which is again equipment and device based, into what is called IOA, which is the Internet of Abilities. So you need a way to to translate the knowledge from an expert to a novice, and there are now systems that we have in place where we do the autonomous knowledge transfer. So we use those types of systems in our factories. So through all these things, we make the work more enjoyable, more engaged. So what we see is we see reduced frustration because we are able to support the process prone to mistakes, right? We are able to find those mistakes prior to them making the mistake, or correct the mistakes using a robot in the downstream. We're also able to do autonomous coaching, basically proficiency-based self-coaching, because everybody has their own learning curve, and you're able to adapt to the individual. We're also looking at increased motivation, because you're trying to do a real-time constructive feedback. We're not penalizing that the operator, like what the Industrial Revolution times used to do, right? So through wearables, we're able to do that. And through the collaboration between men and machines, we have a cobot in the downstream, and if there was a mistake that was that happened with the operator, the robot corrects it, and then it tells them, hey, let's fix this next time. So it's an increased harmony between men and machines. So let's just look at a video. This is, again, in an Omron factory where we are assembling an Omron component. There's a screw driving process that's happening, and the operator tries to drive the screws. And like I said, we are able to see this. Oops, oh, sorry. I'm sorry. Okay, let's see. Okay, sorry. So, the systems that we use, we're able to figure out the best way of assembling things, and we send this to the we use 5G in our facility to send them to the cloud. We analyze them, and we are able to also automatically identify these mistakes, again, give them feedback, and also motivating them, by telling them this is, you did a great job here, or you have to correct in these areas, and so these are real production videos that happen, and it's not just a concept, but we use them in production. So, if you look at the, we mentioned about the collaboration and the adaptive manufacturing. On the horizontal side, you have the machines where it's very process specific, multiple machines, multiple lines production, and a plant. And so these are the assets, and here is the variability, right? So, if you look at so most factories today measure the overall equipment efficiency because they are looking at the ROI. They want to get it as soon as possible, and it's all financial returns. And when we start getting into this area where it's adaptive and adaptive robotic automation, we have the people, humans in this equation. So there are three things that I wanted to mention here in the adaptive and robotics automation, the way that we implement it. The mobile manipulation, combining autonomous robots for locomotion and combining that with manipulation. We call it the mobile manipulator. But basically, it's trying to give arms and eyes, and with adding with the locomotion like an operator. And looking at interoperability, which is why we're all here. So we've been working with the ROS Consortium for over 5 years now, and specifically with the RMF team. We have implemented the RMF in our logistics facility. Again, the first time, I think Luca mentioned that the warehouse is still under development. That's part of what we are doing there. On the logistics side, all of the robots, different types of robots, both the mobile robots and also the industrial robots with the door openers, and other systems, other peripherals. We have been running that under RMF with obviously with a lot of help from the ROS-I people. Thank you so much for that. But we feel, this interoperability becomes very important. Just like it's not just harmony between humans and machines that's important, but harmony between machines and machines are also important, just like the case that Luca was saying, machines to machine interaction, because that kind of is going to be affecting us. So interoperability is key, and adaptive inspection, with AI and where things that as humans we are not able to see, we could use those things. So let's just look at how we do that in our customers' factories. So this is a typical production line where we have distributed process with no specific infrastructure for material transfer except for closing the production loop with mobile robots. So multiple types of mobile robots, right? With manipulators, with conveyors, with feeders, whatnot. And this is actually a real example where we were working with a company, with a life sciences company during the COVID period to manufacture the COVID test kits. Now we had to set it up very quickly, and it had to be really flexible and deliver products on time. So this is where the combination of mobile robots with the fixed robots, cobots, and vision, without specific infrastructure for movement such as conveyors and things like that, was able to really bring up production very quickly, and with very minimal touch. And also on the back end, you've got the secondary packaging, the palletizing, the material movement, and the whole supply chain process. So in summary, if you have to really define, it's still a work in progress. In no way this is a complete definition. We are still working on this. But what we are looking at is as of today, right? Is a shop floor where there is seamless and valuable harmony between people and machines. and making the right conditions for them to be successful in their daily pursuits and being more productive and creative. So it's basically creating a fertile land. I didn't even push that. So it's autonomous. It's creating this fertile area where humans can thrive, right? Oh, I didn't even do anything. So we look at happiness at different levels. For factory operators, when are they really happy, right? We look at when they are happy, when there's zero breakdown, when it's very predictable machine, safety, and quick on-time assistance, and on demand, right? Assistance on demand and prescriptive maintenance, that makes them happy. And again, factory managers, again, flawless execution of forecast, high OEE, no. I didn't even do that. There's some electromagnetic radiation coming from somewhere. So look at factory managers, zero compliance breaches, and maintaining autonomy and skilled workforce. So autonomous coaching becomes key for them. And then the corporate side, improved ROI and agility, connectivity, and so on. And the board of directors is sustainable operation. So I think this harmonious relationship between men and machines and people and machines are very important for a sustainable workforce. So that creates harmony. So I just wanted to conclude, to quote our founder, Takeshi-san, who says, "Through the machines, the work of the machine, and to mankind, that the thrill of further creation." So thank you for the opportunity, and thanks for listening.